Hello YouTube viewers, welcome to my channel Science to Technology. Me Anupam Vipul here. I welcome you to my show Computer Wednesday, and today we're going to talk about CPU, GPU and APU, an overview. Now this video is not intended as a buyer's guide, go and buy this is not intended for that. This core purpose of this video is basically to help you understand how the heck you make that decision, because if you can make the decision, this video will be valid in 2020, 2025, 2030. So for this reason, you have to understand the core component of a computer, that is basically capability, what it is intended to do, like what you're supposed to do with it. For example, a gaming computer made for, let's say, the cutting edge, the bleeding edge graphics and all that, they would be completely different compared to someone that's solely focused on CSGO. Would be completely different. A computer that is made for home theater PC versus a computer that is made for workstation would be different. So for this reason, you have to understand that capability of your computer is directly proportional to your need, and if they align properly, you are in heaven. If they do not align, you are in hell. So computer have this weird tendency is that the computer is only as fast as your slowest component. For example, you can have the best processor out there, you can have best RAM, like you can even have YOLO amounts of RAM, like let's say 128 GB of RAM and best graphics card and all that, but if you are running all of that through a normal SATA hard drive, good luck, just good luck. That will happen. So I recently thinking about revitalizing my old computer, which is like I bought around 2009. Yes, 11 years old computer, and then I realized like it has SATA 2.0 port. So even if I buy a SSD, that could easily comfortably give us around 500 to 550 Mbps speed. It will barely do 300 in a computer. Why? Well, slowest link is that SATA 2. So this is one core component. You have to understand this. You cannot have bottleneck in your computer, because everything else become slow and miserable. So that is the core aspect, and what you're supposed to strive for, rather than like oh, the best graphics card or best processor or best RAM, is balance. Balance is the best aspect here, because if everything is mellow, first you save a lot of money, second every components last longer if they are perfectly balanced. And you have to figure out well, compatibility, suitability with your priorities are a key. That is the reason why Dell could have like a workstation system and an Alienware system. You may be like, isn't Alienware better? Technically yes, but these things are validated for much longer use. You can get warranty as high as 3 to 5 years. Here you can get 1 to 3 years. So that should give you some context of it. These beasts are defined completely different. They have much more efficient power supply. They have you cannot overclock them, you cannot tamper with them. They are like, you buy it and you forget it. And Alienware is like, you go YOLO with liquid cooling and like having 5-6 hot swappable hard drives and SATA drives and NVMe systems and all that jazz. Completely different, because requirements are different. This is like generally would be bought in like, say, a studio, where they're like, I'm gonna buy this and I don't want to think about it, because the reason why I bought this, basically my first computer, basically Dell Inspiron 535S. The reason was that basically I was not very smart back then, simply because, well, this is something that I bought to get on the internet. So I did not knew well enough about computers to realize that slim form factor simply means I could not do much with it. And back in that day, I did not know, but I did was like very aware of one thing: warranty. The Dell was comfortably giving me 3 years warranty if I wanted to pay for that, and I paid for it and I got the warranty. Was it good? It was awesome. I live in India. I live in a small town, and when I had an issue of my RAM not putting blue screen and all that, they sent an individual who just reseated the RAM. Back then, I did not knew that could happen. And then I had a dead pixel on my monitor. They replaced the whole damn system. Again, for a studio, for let's say a large company or a school or colleges, they do not want to deal with the temper tantrum of a shopkeeper, or like, okay, who I bought this part from, or I bought let's say motherboard from Asus, or did I bought the RAM from Corsair, where the service center is. That you don't have to deal with that. You just call up Dell. It's like, bro, this issue, they're gonna take care of it. For many people, that is absolute necessity. You cannot have downtime, or specifically a downtime that you cannot recover from very quickly. So for this reason, people will buy workstation grade system. Assemble computer, you will get tangibly, you will get better everything, but it's just that do you want to deal with warranty and all that? Because if everything works, assemble will be awesome, but one fault hackers, you will be like, yeah, everything else will fall apart. For this reason, that is why like HP, Lenovo, Dell, all these companies have been making assembled computers for like pre-assembled computer for around 30 to 50 years. That is the reason for that. And do not overspend, because you may be tempted. Let's say you want to build, hey, I'm gonna build this home theater PC. All it it's got to do is just basically run, let's say, some 4K Blu-rays, like BLDXD format. Basically it's triple layer and quad layer. So you got the Blu-ray drive, awesome, you spend a lot of money, you're like, hey, wouldn't it be awesome if I put like 1660 graphics card into that? It's useless, it's not gonna help anything. So for that reason, you would be just ending up with a scenario where you have a HTCG that consumes more power than it needs. In case of India, that's a very serious detriment, simply because most of the times we are running on inverters. Power cuts are very frequent here. So for that reason, our basically your home theater system will go down very quickly, simply because it's consuming more power. That is why overspending is wasting power. Not only you're wasting money, you're literally wasting your power. Let's say you need 1030 and you bought like 1080, you're literally wasting power. So capabilities are directly proportional to your need. The more you know what exactly you need, the better your equipment would be, and more stabilized, basically better lifelong you want to spend time with QVL, basically qualified vendor list. Every company has that, at least reliable ones. So let's talk about CPU. This is the core. Basically, this is computer. Everything in your computer works to help this puppy. This is the main thing. Core. It controls everything. Now it controls something mundane also, which you may not think about. It like basically USB port, SATA port. So if you bought a basically, let's say, computer that is like, let's say in the future SATA 4 comes out and you're like, okay, I'm gonna buy SATA 4 hard drive, I'm gonna connect it into my system. It's like, tada, you will be in the same position where I am, because the processor was old. Processor was only compatible with SATA 2. The motherboard used SATA 2. I'm stuck. So this will be a very serious learning experience in that sort of scenario. So you always have to understand the processor controls everything. Can you use DDR3 or can you use DDR4? Can you use the PCI 4.0 or PCI 3.0? Everything is directly proportional on the CPU, and you cannot tamper with it with the motherboard. So this is one thing that you have to basically take a deep breath and think about it. And that's why you will see graphs like this from a company like Intel and AMD. They have a actual use. They are not just some marketing gimmick. Actually, they are most useful than compared to all the fancy videos they make. They are far more useful. You can easily see, hey, if I'm gonna buy let's say a Ryzen processor, what I'm getting 4 super speed USB, aka 10 Gbps class. I'm getting 4 of them directly from the processor. Benefit, low latency. So if you have to connect something that is like a very high priority, let's say a capture card, you're gonna connect it using that port. And let's say you want to connect your graphics card. Ideally, you want it to be as smoothly connected to as possible to the processor. Tada! This has 20 PCI lanes. So 16 lane is more than good enough for your graphics card. Now you're like, why the heck it has 20? Because 16 gives you the graphics card and 4 gives you NVMe storage. So you can have one NVMe card that's working like your boot drive, basically working at full speed with processor, low latency. Latency is key here, because you can get the speed anywhere no matter what you want, but latency is directly proportional to distance. Basically, if it has to go through the chipset, latency goes up. Now it's not too much, you don't have to worry about it, but if you can avoid that, awesome. Then you're gonna have like how it's configured, like pick 1 into 4x. You can have 2 by 2 NVMe or 1 by 2 NVMe or 2 SATA. That is the reason why you will see this kind of diagram. And then it won't be enough. The processor, while it has nowadays has like south bridge, north bridge, everything put into it, is still not like enough bridge, so to say. So chipset are still useful, because chipset will add you small things you do not think about. Basically 4 normal USB port, like, why do I need that? Do you really want to waste your 10 Gbps port for keyboard and mouse? Unwise. For that reason, you will have like basically SATA ports, because again, if you are getting PCI Express out of that, and you're not going to be able to build a low cost NAS out of it, you're gonna use chipset. And chipset also gives you extra PCI lanes that will have a bit more latency issue. But when I say bit more latency issue, basically you can only see that in synthetic benchmark, or if you're running neural networks, you may find like it's lagging a bit. So in those sort of scenario, this sort of graph makes sense. And same you can see that with processor. So let's say you'll be like, hey, I'm hardcore Intel, I'm gonna and you saw basically SSD that is like 4 Gbps read and write, like, whoa, PCI 4.0, whoa, I bought Intel 10, but when you did not read this graph, you will realize this is limited to PCI 3.0. You cannot connect these things. That is why take your time, study this sort of graph, no matter which company you're talking about, no matter which model you're talking about, you'll always see graphs like this. Spend even a little bit, just have a cursory glance, you're like, okay, I get it, what I'm supposed to do. I can guarantee you this. For this reason, you also have to understand that, let's say you put there are generally multiple processors in the same processor family. So you could have like 10th gen i7, there will be at least 2-3. So you may buy a board that can support any 3 of them, but problem would be lowest one will not have enough PCI lanes. So even if your motherboard can physically support it, it will be working at half speed or quarter speed, depending on how much you oversaturate it. For this reason, especially for workstations, people generally spend a lot of money to get enough PCI lanes. Why? Because maybe you want to add a graphics card, maybe you want to add a let's say red camera's video accelerator. Maybe you want to add a 10 Gbps network setup, or maybe a PCI SPF port where you can directly connect optical. You're like, I don't want to deal with basically network hoo-ha. Just give me optical system for every editor. It can be done, but you need PCI lane, and you need strong PCI lanes where they have enough bandwidth, because everything will work. That's the one good thing about PCI. PCI was designed in that way that it could work backwards and forwards, and multiple lanes also. It will work. That's the awesome part. Side effect: it will work at compromised speed, and you will not know why. So that is why you always have to understand CPU as a system, because it controls everything. You cannot be like, okay, I'm gonna cheap out on basically processor, and I'm gonna buy a motherboard that has 6 PCI 16x slot because I need this. It won't work. It simply won't work. That's why CPU is the bottleneck. Every bad computer that you will see, every bad computer people are complaining like, dude, this is a really bad experience. Simply, I can guarantee you 99% of the time it would be because of the processor acting as a bottleneck. Basically, I bought this computer that I was showing you. It's 11 years old, 2009. So it's 11 years old, and I can put let's say 10. I can put 1030 or 1660. If I put 1660 on this, it will barely utilize that. Like my frame rates would be still 30 frames per second. Why? Because the processor is not feeding it. It's like O2 Duo. This is the core aspect. Spend time, take a deep breath, spend time, try to understand these graphs, which are quite easy. Just read it, and you will be very safe for the long term. Now let's talk about GPU. Now GPU are the easiest to upgrade, because when I bought this and I realized this basically graphics card 512 DDR2. Yes, this has DDR2 VRAM. I don't know why. It was basically useless because it took literally half an hour just to run Crysis, as in like launch Crysis. Running was like I had to run at 720p and all that. It was painful, basically painful. So I upgraded that. Again, that's the easiest part. I can easily upgrade the graphics card whenever. And that, even if you have a scenario where you're choking it, you can improve your experience tremendously. So it's the easiest part. Like you can literally skip this part if you're buying APU, or if you're have Intel and it has IG integrated GPU. That's the easiest part. Like you can literally get a computer, start working, and if you are especially working online or remote and all that, basically where you have to deal with things that are outside your control, you don't have to buy a GPU right now. But it does come with one weird side effect that right now, as in 2020, is the least used part. You can have a computer and you're not doing your work and everything is going awesome. You'll see your CPU is around 30 to 60%. Basically, your GPU would be generally most of the time zero. GPU are not utilized, and I'm saying that as a 3D game artist. I worked in basically Halo, worked in Spider-Man and Forza and all that jazz. I can guarantee you, unless you are running the game engine, most of the time when you are doing baking, normal maps and all that, we beg for companies to give us equipment that allows us to utilize the graphics card, but it will only use processor. So right now we are in a scenario where companies are like literally selling us that, like, buy our equipment, buy our software because it uses GPU. Like DaVinci Resolve, what's the selling point? It utilizes GPU, and you can see that's a tangibly unused part. Like these components are very high powered, and you can easily see that. Like for example, I downloaded a very big movie file, sample file. It's huge, as in like freaking huge, and it does not run well on VLC. I'm like, why? I have like 16 GB of RAM, bulldozer, and 1070 Founder Edition. Why the heck it's not running? Because it was not using GPU. I downloaded Pot Player uses GPU, everything is butter smooth. So you have to realize that like graphics card is very ludicrously unused part, especially in home theater PC or a work PC. It's just not utilized. Most of the time they are just treated as a fancy display adapter. So that is one painful aspect, especially for work professional, not for gaming. For gaming, you have to have this. But for work professional, is that we have so much teraflops and nobody is utilizing that. Right now, it is changing slowly. People are realizing that, DaVinci Resolve and even Unreal Engine, and there are some other rendering systems for games and Marmoset and all that. They are like, yeah, we have to utilize GPU. So it's very less used part. So especially if you are building a workstation, make sure your software can use that. If it does not, buy something cheaper in terms of graphics. Basically, don't buy something too old, because you do want driver support. So if you can have, let's say, a GTX 710 versus GTX 1030, go with 1030 simply because it will have longer driver support. Or maybe even go with 1650 simply for driver support. Driver support is very critical, especially for work systems. You do not want to tamper with driver. You're like, dude, give me best latest drivers. So this is the GPU aspect, really annoying and frustrating for the working professionals. Now there is a new kid in town, APU. People realize this very early on. It's like GPU was always treated as a luxury. It's like, you add it on at the other end. But because GPU started to grow in popularity and slowly started to become actual thing that people put in servers, people realize, as in like high end people who are controlling these companies, like, hey, if we can put truly good GPUs on processor die itself, we can get some extra performance out of it. Right? Before this, they used to make something known as iGPU, integrated GPU, which is Intel's bread and butter, but it was like bare minimum effort, like bare minimum. Somebody thought, it's like, let's try to put whatever we can put in with that limited technology. It was damn amazing. And I'm like, was it amazing enough compared to a normal graphics card? Hell no. But what's the point? It was utilized most often than not. Like, you can literally run a VLC and you're like, okay, I need to decode this video. Processor itself will be like, I got this, bro. Send it the data to the GPU and GPU decodes it. Everything is smooth. So you can literally run files that are like 100 Mbps, which many uncompressed raw files are even higher than that. So in those sort of scenario, you will be like, processor is like, I got this, man. I got this. Why? Because it has an integrated GPU. So it tries to give you best of the both world, where you do not have to like, okay, I have a huge component which I rarely use. So basically APUs are very awesome for home theater system, because you do not need a graphics card for just decoding Blu-rays, but you need something better than integrated graphics. Ta-da, APU. And it generally utilizes basically your main core RAM as a VRAM also. So you can find odd setups where you're like, okay, 12 GB of RAM. You're like, why the heck it's 12? Shouldn't it supposed to be 16? You're like, because 2 GB is dedicated for the VRAM. It acting as a VRAM, basically it's quadrant of software wise. So that is why it's not generally recommended. APUs are generally not recommended for user. So if you are a heavy user, don't even think about it. If you're a professional, don't think about it. Gamer, don't think about it. So for home theater PC, and generally even there, I don't recommend that most of the time, simply because you have to spend a lot of time to first A, get it actually working, B, you have to figure out how the heck RAM compatibility works. Generally this is well suited for laptops, because laptops integrated graphics is generally the best option, and even if you have a dedicated graphics card, your computer will literally do not want to use that, simply because it will consume battery. So if you're like you want to sit down and game, you will connect an adapter, graphics card is go. But when you disconnect it, it's like, oh, okay, let's shut that off, because that's going to drain the battery in 5 minutes. Let's use the integrated GPU. So in those sort of scenario, in laptops, in small integrated systems, home theater PC, it's amazing. It's like next bread and butter. But for actual work, don't think about it. Don't even touch it, because you cannot change it. Once you buy it, you are stuck with it in terms of graphics card, because this will also make your motherboard more expensive, because it has to have the video inputs and output. And right now many companies don't want to give that. It's like, just give a PCI slot. And again, PCI slots, I rather have better PCI slot than integrated crappy graphics card. So that's the whole point with APU. Generally try to stay away from them unless you know exactly what you're doing, unless you can read through like pages and pages of how to configure it, how to hack VRAM will work, and can you change it. Basically some scenarios you may not be able to change it. It's like, yeah, it's limited to 2 GB, even though your video game may not be intensive in terms of processor, but it'd be like, bro, I need 4 gigs of RAM just to load up the texture. Especially when you see people modding Skyrims and all that, it becomes an issue. So that's why I generally say away from this, but it has its own uses, especially for laptops, NUCs, and home theater PCs. These are quite amazing for those applications. So this was my presentation. Hopefully this would have given you a more fuller picture of how the heck things go together. Hopefully this was helpful. In that scenario, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.